welcome to another office hours session on how to do JSON in the database. I'm Blaine Carter. I have a cold today, so I'll probably limit my interaction a bit more than I normally do. But then you're in the capable hands of Beta, who knows everything about JSON and Oracle and how they mix. So I will let Beta take over from here. If you have any questions, type them in the chat and I will try and keep up with the questions, and I'll break in and read the questions off as they come in. But take it away, Beta.
Thank you. Thank you. Well, great introduction, but I'm pretty sure that I don't know all of it. But I like how you told it to me. So yeah, today we're gonna have, let me just close these windows so that I don't get disturbed here, and let me share my screen.
The way I like to say it is I actually know everything, I just can't remember it all at once.
Exactly. So can you see my screen? I'm using Live SQL.
Yes. Yep.
And I just made the script public, and let's just see if we can find it. If I just go to search for JSON path. What did I click wrong now? Home, search scripts and tutorials, JSON path. Okay, it's this one here. JSON path expressions and simplified syntax. This sounds extremely boring, and I hope it is not too boring. I will go into some details which I believe are quite interesting if you work with JSON and you want to make sense of some of the results. Sometimes it is interesting to understand the inside the data model and what's truly happening. I will also talk a bit about some extension we made to the path language, which are interesting to those that have not worked with version 19, for example. So I'm creating a pretty dumb JSON here, and it basically is just a value A, and A is an array. And I put all these different data types in there. So we have a number, we have a string or several strings, Boolean values, null, and then a nested object and then a nested array. And I want to use this pretty stupid data just to illustrate how internally these path expressions are processed and what the functions do on top of that. So today will be about the path language, how internally these things work, and also the syntax of how we simplified it. So I just create a table. I use a CLOB to store it. There is an isJSON check constraint on there, and that tells the database that this column holds JSON data. So now this is the simplified syntax that I think all of you are familiar with. And we're selecting from this table T, the column, and then we use the dot to navigate inside the column, basically to extract the value that is associated with this key A here. And one thing you have to keep in mind that you have to give an alias here. So if you remove this T here, or the alias, which is the table name and the alias have the same character here. If you remove that, the simplified syntax will stop working. So that's a requirement we have. But you get this value back, and it's a varchar 4000. That is the only data type that the normal simplified syntax can return you. So what we've added, I'm not sure in which version we added it, might have been 18, I guess. We also allowed you to use the square brackets to navigate inside an array. So the dot navigates inside an object, and on top of this dot A, I could have a dot B, dot C, etc. I can have as many steps to navigate through my data structure. So there is this dot A, which is the dot which navigates to object fields, and there is the square bracket which navigates inside an array. So our A value is an array. So with a square bracket 0, we're navigating to the first item in here. So this follows JavaScript syntax and semantics, where the square bracket takes it's 0 base. So an array, the first item is a 0. So we see that this one value is being returned. One thing to keep in mind that this one here, or the data type of this column A, would also be a varchar 4000, because that is all that the simplified syntax returns. So now the interesting part is, instead of the 0, I can also put in the wildcard, which means go to this array and select every item inside this array. So now the result looks the same as if I had selected the entire array. So here we're selecting the array, we get all these values back. Here we're selecting all the items inside the array, and the results look exactly the same. But internally, something very different is actually happening here. It's a bit of it's maybe kind of leading to the assumption that these are semantically equivalent, but they are not. So the difference is here we're selecting the entire array. This is one value that is being returned. Here internally, we're actually selecting each of these individual values. And because we can only return one value, we've wrapped them inside an array. So it's the array wrapper that turns this entire result into an array, whereas here in the first case, it was an array in the first place. So it becomes a bit more clear if you don't select everything using the wildcard, but if you use another array subscript that selects more than one value. So 2 to 4 selects 3 values, in this case, cat, true, and null. And the array is automatically added. So it's wrapped, these 3 values are wrapped inside an array in order to return this as one value. I hope this makes sense. If there are any questions, just put them in the chat and Blaine will stop me and I can explain it. So this is, I believe, a fundamental thing. We may something about this in the documentation, but most people don't get such a deep understanding of what these path expressions actually map to. So now, an addition we've made is these trailing functions. So you can say, given a path expression, the last step can be a function. In this case, the example, it's a size function, and it would count the items inside this A array. So we see if we select the array and we do a dot size function, we get an 8 back because there are hopefully 8 values inside. This object and this array are one value, even though if they have internally some more values, they're treated as one value inside this array. They're complex values. All the other ones are scalars. They're scalar values, but a nested object or a nested array would still be one value, which is complex. So this is an example for the size function. It returns us the value here. And this will actually be a numeric value. So if we compile this query, we know that size will give us a numeric value back. So this would be a number SQL type. So now another trail. So this is an example of a trailing function, which gives you information about a field. And this is a conversion function. So you can say, I want to select the first element or the first member of my array. And I want to convert this to a number. So remember here we had selected this value already, and I told the one that this is a varchar value. Let's say we want to use this expression in a word clause, and we have a range comparison, for example. Then we want to do a number comparison of this value and not a string comparison. So just by adding this number trailing function to the path expression, we do get this value 1 as an or a number back to SQL. Similarly here, if we look at the second item in the array that has the index 1, and that is the string 1. So this is a string value 1, and the number function converts it to the numeric 1. So it will try to convert it, and in this case it works. If you use dog or cat and try to convert this to a number, it will fail. Now, yeah, this is the 1. This is the string comparison. The second value was a string. So now there may be a case where you want to convert a number inside your JSON to a number in the SQL domain, but you only want to do it if the original value was a JSON number. So you don't want to convert strings that happen to be convertible to numbers. You just want to treat them differently. This is what this number only function does. The name is a little odd, I agree, but it's saying convert me something from the JSON domain to the SQL domain and we want to do a number conversion, but this only restricts it to really true numbers in your JSON. And number is only an example. We have the same with a string, for example. So you can have
There's
string.
a question, Beta.
Yeah.
Output of T column A and T column A bracket star is the same except call dot bracket star process. Is it different? If yes, then when do we use either of them?
Hold on, where do I see the chat now? Just want to take a look. Okay, so the output is the same here. That is correct. The output is the same because it's getting converted to a varchar value. I gave this example, and I agree it's a bit artificial to say that these two outputs are the same, to motivate the internal machinery. And I think it becomes clear if we use subset like this. This is just to illustrate that something that looks the same may not be generated the same way. So for this specific example, I would probably say if you select everything from an array, you might as well just select the entire array. But the moment you have subset, array subsets, or other things, then it's a different use case. So I think the use case drives it. There is no, if the result is the same, you should probably use the simpler version to generate it. This is really just to motivate the internal model of the machinery, what's happening. Okay, so this is the example of this number only. So if we select this second value in the array, which was the string 1, then the number only function will not convert it. So we get a null value back because it was not a number value. Another example of these trailing functions is type. So we can ask a value what type it is. So it will tell us this value at index 1 is a string, and the type of the index 0 is a number. And if I call it on the array itself, well, that type is an array. And I don't have an example here for the object, for example, but you can imagine that these types here can be objects, they can be Boolean. Null, I guess, is also a separate type here, because in JSON, null is its own value, so to say. So it's Boolean, string, number, array, object, etc. So now you might ask yourself, what happens if I select everything inside my array and I call the type function on it? So let's look at these steps again. So this dot A selects the array. Then the square bracket star selects every item inside the array. So now we call it sequence. It's a term we have not used in the documentation, but when we evaluate this path expression after this square bracket star, we have multiple values or a sequence of values. And then we want to do the type function on top of that. Well, it's multiple values. This is why in the simplified syntax, this type function also returns you null. It's basically not possible to use type on more than one value. We will see later that it's possible in some other operators. Good. So this was this part here was to show trailing functions and that you can use these array subsets inside the simplified syntax, and also to show you a bit about this internal data model. So let's create another example where we want to use the simplified syntax, not on a table with an isJSON check constraint, but we want to use the simplified syntax on another SQL expression. So what I do now is I create a simple table emp. It's kind of a model of this emp table that is used in the sample schemas. I insert a few employees, and now I use the with clause to create a JSON representation of my relational data. So I have a subquery. It's JSON object from emp, so I'm converting these rows into JSONs. And now I use I refer to this in my query. So I say with emp.json, that is this subquery, I want to select the no, so let's go a bit more into it. So in the from clause here, this is what I've defined in the with clause. This is the column name. So we will see my emp.json is aliased AEJ. So I have EJ selects this subquery, value is this JSON object. And now this part here, this dot emp no, is basically using this dot notation inside the JSON that we've just generated here. So why is that possible? We're not using, we don't have any isJSON check constraint in this example. So our value column here has no isJSON check constraint, but the database still knows that this is JSON because this value originates from a JSON generation function, in this case, JSON object. So the database, when it looks at this SQL expression value here, it knows this is JSON, so I am allowed to navigate my way into it. But what happens? Yeah.
Why isn't it applying type to each element of the array and returning an array of all of the type strings?
I think we get to that later in the same presentation here. I can answer that in a second. Let's make a simple modification to this example. And what I do is I have this same JSON object expression here. So I'm generating JSON, but then I add an empty string to it. So I use this is the string concatenation. So now my expression value is not directly a JSON object, but instead it's the concatenate operator on top of a JSON object. And this leads to an error at semantic analysis, where we say, well, it's a bit of, the error message maybe not the most meaningful in this sense. Maybe we could think about a better error message, but it's now saying, well, emp no cannot be used. This is an invalid identifier. And the reason behind it is that we lost the knowledge that our val column holds JSON data. We knew it in the first example because of this isJSON check constraint. We knew it in the second example because the value originated directly from a JSON generation function. But here, now value is an arbitrary SQL expression, which happens to be a varchar value. But dotting your way into an arbitrary varchar value is nothing that's that has any semantic meaning. So this is why we erase this error message. Another example with the same problem is if you create a function, a PL SQL function, which returns JSON and returns it as a club or a varchar. So here it doesn't really matter what the function is doing. I used a similar example where I generate a JSON object from something, but this could be anything that generates JSON. The moment you call it, it is not known anymore that the value is JSON. So this knowledge about a value being JSON is not propagated across these function boundaries. So in this example, what we do is we select from our function, use that again in the with clause, and then we want to use the dot notation, this dot x, which I know is part of the JSON object being generated. So we get a different error message here. Again, not a really one that tells you what's happening in the context of JSON. So those are both generic error messages. These error messages have nothing to do with JSON. The Oracle is basically complaining that this .x is not executed on a object type or not on a type that has this dot means of getting into it. Yeah. So the solution to this is a little operator which I think is not well known, which is called TREAT as JSON. So if I modify the query slightly and say, well, I'm not only selecting foo from dual, I'm selecting treat foo as JSON. Then at semantic analysis time, we know that foo is JSON and the simplified syntax is allowed again. So this is one common use case is really if you use the dot notation with the with clause, that very often it's not working unless you use the treat as JSON clause. Or similarly, the example with JSON object and the string concatenation, if I just tell treat this expression, treat this arbitrary expression as JSON, it's a hint to Oracle to allow the dot notation. So we see that we can dot our way inside the inside this object. What treat doesn't do is actually validating that what you pass is JSON. So here I'm using some garbage data and tell it, well, treat this string literal as JSON. While it won't select anything meaningful, it's returning null, which is the default for something didn't work in the simplified syntax. So how can I check that whatever I put into treat is valid JSON? Well, that's what the isJSON clause is doing. We don't have to invent anything extra. I'm just adding the same expression value into my where clause, and I would see it now that it's not null returned, which gives you a row which is null, which is kind of the placeholder for something didn't work right. But instead now this value wouldn't even be fed into the select clause. Good. So this is about simplified syntax, what it can do and how you can enable it in cases where it's not working right off the box by using treat as JSON. And now let's go to the full syntax with the trailing functions. This is, I think, addressing the question from Judith. So here, this is the difference between the full syntax and the simplified syntax is that the full syntax, you have these operators like JSON value, JSON query, which are also part of the SQL 2016 standard, and they have a lot of options like returning clause, what to do on error, or default values, etc. So these trailing functions can also be used in the full syntax. So here we see the type is an array, the size is 8, and now this was the question, what is the type in JSON value? Okay, now let's go through it. First question, why is this returning null? Statement 32. So let's look at it. We're selecting the document. We're going to our array using .a. We're selecting every item of the array. So now we have multiple values, and we call the type functions. Well, the hint is with multiple values, JSON value is returning you one value, and the moment you have multiple values, it can't return it. So by adding this error on error clause, now instead of a null, I get a meaningful error message back. So the simplified syntax, whenever you see a null value, it may be because of, well, it auto-wraps multiple values. So this case would be handled in the simplified syntax, but for other cases where you have invalid JSON, etc., you wouldn't see the actual error message. So that's a reason where you may want to consider the full syntax using JSON value or JSON query. Okay, so the error message is it probably got some values, but it can't return them because it's the wrong function. I should be using JSON query. So let's use JSON query, and we're using the with wrapper clause, and we get now an array back which has all these types. I think this is addressing the question from Judith where she asked, why don't I get back an array of all the type strings? And you do get it back here. I'm not sure if the simplified syntax, if this is not working by design or if this is an open bug, so I have to check on that. But here at least it's working, and this is the way it should be working, at least for the full syntax. And it may be intentionally that it's not working in the simplified syntax because it's maybe expected to return you just one type back. So similarly, I can use the size function. So now I again select all the items of the array, and for each of them I apply the size function, which converts each of the selected values into a size value, and the multiple values are wrapped inside an array because I have this with wrapper clause here. So you see back that every scalar value counts as a 1. The object head was an empty object, its size is 0, and the nested array had 2 members, so its size is 2. So what I can't do is I cannot use a function on top of a function. That is a current limit we have. So I can either do type or size. I can't do type and size on top. So you will see an error message for that as well. Good. I think this one here should also go away. Let me just remove this. No, I'll remove it later to check it. I think this was another thing that I need to look into. So what's happening here is, I can just quickly explain it. I want to use this number conversion function, but it's not doing the conversion. This is a bug. This is something we need to fix. See, I'm honest about what's happening and not. So the trailing functions are relatively new, and these are some cases where we don't have apparently fully fixed all the open issues. So let's go back to the next step, 38. So we're selecting the first item of the array, and we're using this returning number clause. This is very old, all of you know this. This is actually equivalent to using this number trailing functions. So you basically have 2 ways now to express this conversion. You can either use in JSON value this returning clause, or you use this number trailing function. So if you do this, we also change the SQL type of the returned value to be a number to map it. And there's also not only number, there's also double, float, date, etc. conversion functions. Same stuff that I've illustrated. This number function converts strings and number only filters. So our string 1, this is selecting the value 1, but not a numeric 1, but a string 1. That will be filtered by the number only function. So it's checking also the type. So you could kind of thinking that this is a predicate. The JSON path language also has predicates. So you could say, well, I want to convert number, and I add a predicate to the path expression saying that the type has to be a number, only then I want to have it. This is kind of short for both of it. Good, yeah, so if it is number only and we use arrow on arrow, we actually see the proper error message that's happening here. So the message here is that these trailing functions are not only available in the simplified syntax, but also in the full syntax. So let's go to another test case. Any questions till here? If not, I have
so far.
Nothing so far, good. So I have another example here where I want to show you about predicates. So this is some JSON about persons and their skills, and the skills are an array. So everyone can list what skill they have and how good they are. I have 2 rows, different skills, different proficiency. I also add an empty row here. And now the question is, I want to find out people or skills where the proficiency is greater than 80. So we see here, Jonathan is pretty good at Python and Geeta is good at Java and C. So I only want to find out, let's say, persons or skills where people are really good at. So in SQL, you would say, let's say the threshold is 80. We would use the simplified syntax. We're selecting our column. We go to the skills array and we use the proficiency. So implicitly, we didn't do a square bracket star here to iterate over the skills array. This is done implicitly. So we call this lax path processing. If you have an object step applied on an array, it means a for each. So dot proficiency will basically be applied on each object inside the skills array. In the long version, there would be, if I didn't want to have, let's say, I mean, we do lax processing without the user telling us, but you could also do after skills a square bracket stars if you wanted to make it obvious from the syntax that skills is an array. So this fails. And the reason it fails is that we're trying to do this comparison in the SQL domain. And in order to do a SQL comparison, we have to have one value at the right side and one value at the left side, which we kind of have, but this value here will be an array of all the proficiencies. So it will start with a square bracket. Yeah, this is where we see it right here. I have just selected it. So we're trying to compare this value with 80. And that obviously fails because none of those values here could really be converted to a number, because there are multiple numbers wrapped inside an array and then returned as one varchar value. So we constantly have these, the SQL domain. So this is in SQL, or from a SQL point of view, this is one varchar value, but it actually reflects or contains 3 JSON values in our semantic data model domain. So this just doesn't work. I can't use the simplified syntax to do the comparison. That's my long message short. So we have to use the full syntax. This was in the where clause. I'm still in the where clause, but now I want to do some filter. And the full operator, it's called JSON exists. So it is checking for data or some values having some properties in my JSON, and then it's either saying yes or no. And we're using our full path expression starting with $, as a string, and we're using a predicate inside here. So this means go to my skills array and evaluate this check. And the check is go to each proficiency value and compare it with 80. And now we see that this is being returned. So we had 3 rows. The last row was this one here, the empty object. That one got removed, but we see this as a result, and that's not, maybe that is satisfying, but it is not really giving us the skills that have a proficiency greater than 80. It's just giving us entire rows where at least one proficiency is greater than 80. But we really want to know Java and C and Python. We don't want to have the values that are smaller. So for that, we need to put the predicate also into the select list. So here we're selecting the entire skills array, and that array can also contain skills where the proficiency is less than 80. So we also need to do some filtering in our select list. So I'm using now JSON query with the same path expression and the same predicate. And now we see that the, now what's this? Hey, this used to work. Proficiency. Oh no, this is again interesting. Why am I seeing this? I'm getting confused myself. Anyone here, why am I seeing this? You can type it in the chat. I'm really going into the internals of this, this path language today. I created this about 2 weeks ago, and that was long enough for me to...
So there's an answer in there that says you're asking for skills with an S, not skill.
That might be the case. JSON skills. I actually haven't thought about the typo here. Skills. No. Yeah, I think this is correct. Yes, this is correct. So if we look again at the data I'm inserting, so there is skills, And underneath skills, so skills is our array, and inside we have each skill. So now here, what we're doing is we're selecting the entire skills array. And this is a check that's been applied. So once this is met, the entire skills array is selected. What we want to have instead is, so hold on, is this here. We want to apply the check on each of these items. Okay, now we're going really into the details. Here I'm selecting the entire skills array. And if this predicate is satisfied, I am selecting this array. Now, if we add the square bracket star here at the end, we're not selecting the entire array, but we're selecting every item inside this array. And for each of this item, we are evaluating this test. So the granularity of our check is now not the array, but each of these array members. Does this make sense? See, it even confused myself. So now we get these members back, and the check was done for each of this member, not for the entire array. So there is it sounds complex, but there is, it really is different semantics, whether you want to have the entire array back or whether you want just the items of the array back that satisfy a criteria. Good. So this will select us the entire object of the array. What I can further do is I can navigate to just the skill part of it. So this is the expression. I think what if I am interested in the skills that people are proficient in, and this is the path expression. I go to the array, I go to each member of the array, I evaluate my filter, which gives me this big object back. And then for this object, I navigate further to the skill value, and I'm selecting multiple skills, and this wrapper clause will return them as an array. So I get back my Java, my C, my Python. This is the third row where the object was a null. So if I want that row to be filtered, I need to use the JSON exists clause as well. So that is the query that's eventually giving me what I want. So now I leave a second here for anyone who's has some questions or thinks I need to explain this again or differently. I think we got it now. Basically to the point where you see, I think it can't get a lot more complex like this in path expressions. Because we've shown everything. We've shown it like how you select, how you prune rows. This is filtering rows. This is selecting fragments of the data. This is how you get to the data. You filter it further, further navigation for the final result, and then you wrap it to get an array back. I think this is kind of as complex as it gets. So if you understand this, you can call yourself a JSON path language guru. Well, we call it put a count function on the end, and we even got trailing functions in here. Good. Another thing, since we were talking about simplification, is the simplification of JSON table we've done. This is just an example of the full syntax that we started with when we came out with JSON table, which was 12.102. That's a same data set. I'm extracting the name of every person, and then I have this nested path where I iterate to every skill. So I'm going to my skills array, and then I iterate over each of the skills. And for each of them, I project out the skill name and the proficiency. So for our 3 rows input, we get 6 rows output. So you see for every skill, we get a separate row. The last row with the null values, this is again our empty object. So now we simplified this. So I guess some of you have worked with JSON table. So we simplified this using this nested clause. So you don't have to write JSON table, but instead you can just say, this is my base table, nested is the column, this is the columns clause. So I have the name, and then what was here, the nested path, is just the keyword nested. And I don't have to list the data types and the paths for my column names. Instead, I just list the column name itself, and it's deriving the name from the column name. The difference is that here in the full syntax, I could say skill_name is the name of my column. And when we derive the name from the JSON name, it's basically called skill or proficiency or name, because these are skill and proficiency are the fields inside the JSON. I think this is a big simplification. So this was some work we've done to shorten the JSON table and to make it just easier to unnest your JSON data. This would now, I mean, if you derive, so what I've shown here is that if you just say skill, this will be a varchar, and the column name and the key names have to match. It actually honors the case sensitivity, although we don't see it here. This looks like uppercase, but it should actually be the same case as JSON does. And you can also, if you are not happy with the default of a varchar 4000 data type, you can also say this is a number. So this simplified syntax is not really a different or alternative syntax. It's really just a shorter syntax. So you could also add a path clause here if you want the name and the name of the column and the name of the field to be different. So this simplified syntax can gradually grow again into the full syntax if you need so. So I think this is a very neat thing. So now this was just to show that we simplified JSON table. And one interesting aspect that Judith brought up, I think 2 weeks ago, is that she observed some odd issues if she used multiple expressions. She was using a JSON query and the simplified syntax in the select list. So I have an example here where I'm using JSON query to extract the skills, and I'm doing some filtering. I use JSON exists, and if I print a plan of this, I'm not really interested in the result of this query. But if I print the plan, I see a JSON table evaluation. So what happened? So what happening was that instead of evaluating the JSON query and JSON value and JSON exists separately, in this case 4 different functions or operators, we rewrite it to an equivalent JSON table statement. And this is why in the plan you don't see JSON query or JSON exist. Instead, you see the JSON table evaluation. There's still a JSON exists here, but it is still running JSON table basically. Good. Simplification, the last part, then we're done, is for generation. This was the full syntax. If you wanted to generate JSON from, let's say, a relational table, so you gave it, this is the key name I want to use, name, so we generate a key name, and then we add value and the other column, which is the corresponding value. So this was the full syntax to create a JSON object from a row. First thing we did, or one of the things we did, is to also allow you to use the colon as separator instead of the word value. This is more JSON-like, where a key and a value are separated by a colon. And it also allows you to have, if you want the key name to be the same as the column name, in this case job, so you don't want, so here we have position, we want to use the key name position in our JSON, and the value is originating from the column job, so we have to use different names. But if you can use the same JSON name as the column name, you can actually just write job. And this is both the key name as well as the column name. And the case sensitivity is also honored in this case. So in the easiest case, you can just write JSON object, ename, and job, and it's deriving these key names from the column or even a wildcard. So this is the easiest thing. If you just say JSON object of star, then it's turning your row and taking every column and convert it to a JSON object. Good, so this covered, this is the end. This covered the syntax simplification we've done, and really a deep dive into the semantics and syntax of path expressions and the internal model that's being used to select the nodes and return them using array wrapping, for example. Okay, I'm done. Any questions?
Yeah, there's one question that says you replace JSON table call $sign with nested call. What if we have specific path and not just $sign? Do we need to say JSON table?
Let's go back here. You replace JSON. So this nested has basically, no, I think here you can do column. You can nested call .a.b. That would be possible. This is implicitly the $, but you can use the, if instead of call you say call.a.b.c, that should be possible. You don't need JSON table for that. Any more questions? Let me, okay, I'm back here.
Yep, I don't see any more questions. Oh wait, there was a add-on to that last question. Is there or will there be any way to query the keys and not the values, such as the SQL 2016 key value?
Will there be includes the future. So I think, I mean, I cannot promise anything, but it is something that's been requested more than once. So I would say we're working on it, but I cannot give any definite timeline. Right now, I believe you would have to use a workaround, either writing some PL SQL code. I believe in PL SQL, we do have a keys function or get keys. So one could kind of model around using PL SQL code to do that. But I think eventually we will have some means to do that in JSON table. I'm not sure if we're going to do the key value method. The problem with this key value method as it's defined in the standard, that the value could be very large and you would be generating potentially big intermediate results, especially if you're only interested in the key of something. Then I'm not sure if we're going to do really key value or something like keys. Hope you liked it. Thanks a lot for the interest. And if you have any suggestions or open questions, you can always email me or tweet me, and I can incorporate that into one of the next AskTOMs.